Hey everybody, this is Larry. I'm gonna do a virtual contest on the last one that I missed because I was out. I was just out. Uh, I do have a little bit of an advantage of knowing that like people finish really quickly. But either way, it's good practice. So wish me luck. Let me click on this. All right, let's go now. Ooh, wasn't I already here? Why'd I have to click on go to? Okay, cool. Yeah, I mean, just going through it now. Yeah, as soon as I saw this poem, I kind of just read the poem. It seems straightforward. The distance uh, between 2 points are always going to be dominated by the dimension that's farther away. And then the only thing that I looked back up was to see that you have to go from point to point in order. And because of that, then you only need to worry about pairwise points. Uh, and it immediately, yeah, then you could break it down from uh, give it an O of N list to N sub problems, if you will, and then just go through it directly. Um, yeah, and that's essentially what I did. I think I got through this very uh, straightforward way. I think what I wanted to do was actually use like zip or something like that, but I wasn't familiar with the syntax, though. I think now I can, now that I'm looking at it, I know how to do it. But at the time, I was just like, okay, this is a easy problem, get it done. Also, of course, I have a much more intense internal clock because I have to knowledge that knowing that you know, that people finish the entire contest very quickly. Not necessarily this poem, but I know that it's possible. So it is definitely a little bit of an advantage, um, but you still have to solve the problem. Yeah, that's pretty much it. Ran the tests. I was very confident about it, and also, it's not a real contest, so that's I just kind of YOLO'd on this. But yeah, the second poem. Um, yeah, I'm just reading the poem right now. At this point, I thought that yeah, I thought that I would have to do some kind of connected component or something like that, which is usually solved via breadth first search or depth first search, or maybe even union find, and then just kind of like connect the dots that way, and then count the number of computers. But then I think I don't begin to realize that okay, it's just the same rows and columns, and they could match whatever. So I actually don't really need to know anything else other than the rows and the columns. So I just think at some point, maybe not like at this very moment, but like soonish, I'll just kind of figure out what's a good way to attack this problem. I mean, at this point, I realized that yeah, you only need to keep track of how many things are in the same row or same column and same row, and then as long as you do, um, and as long as something matches anything, then it's good to go. So that's all you need to do. And I was going to do in two pass in which I just um, yeah, go through it. I wasn't sure if this is. I guess there is M and N. Basically, yeah, just counting or keeping track of number of items on each row and column, and then that's it. I actually have a bit of a, I wouldn't say a typo. I just kind of didn't really get this. But I'm just typing it in. But clearly, I was like 4. That doesn't make sense. And I look at my if statement. I was like, oh yeah, I didn't even check if it's either 0. This is still wrong, but it's still relatively straightforward. Yeah. And I was like, okay, this is still wrong. Why is it wrong? Oh, okay, because I didn't have like the parent, so that it was just ordering it out. And then now I realized it's still not right. It's like, why are they matching? Like, okay, oh, because it's greater than 0 instead of greater than 1. After that, I was kind of confident, so I think I submitted right now, and it was good. Oh, search session system. Uh, yeah, the funny thing is, I think at some point I had an interview problem that was related to this problem, or like very similar-ish actually, where it was like auto-completed suggest. Um, so I was immediately thinking of like tries and stuff like this, and I was solving with tries. And to be honest, I don't know if in a real contest I would have solved it with tries or what I end up doing, because I think this is a point where knowing that people solve this very quickly became an advantage, because I was like, okay, I could do tries, but it would definitely take longer, so I wasn't sure. I knew that the results would have to be sorted, so I just sorted all the products to begin with, and then, but I think knowing that this problem could be solved quickly uh, prompt me to take a more brute force route about it. And actually, at this point, I misread the constraint that I thought each string can be 2 times 10 to the fourth versus the summation of all the lengths. So I definitely worried a lot about the one-time complexity here. And I think on a real contest where I would not have known that ahead of time, I might have implemented with a try or something like that to be safe, and that would have cost me a lot of time. So, but this didn't happen here. Excuse me. But yeah, instead I just opted for a lookup table where I go for each product and then store the prefix and I just keep track of it. I probably could. I think at this point I was thinking about how much optimizations I need. Yeah, I went with kind of just being lazy for now, and then kind of chop them as I need to. But I can type default to that. Yeah, now that we kind of create this prefix lookup table, almost similar to a try, to be honest, in the way it's constructed, except for it takes way more memory, obviously, because each link is much longer. But essentially, it's still like a try-e thing. And then now I just know that for each kind of subquery, we can just look it up with the lookup table, and it's pretty straightforward. I think I was just trying to type it out very quickly. I think definitely on the pen we could have been smarter about. Actually, now that I look at it, we could have definitely done a quick, make sure that it's less than 3. But I wasn't really worried about memory. Or at least like it was gonna always, like it wouldn't be that close on memory. Either I fail it by a lot or I was gonna pass. So yeah, here we just kind of use the first 3 entries. Otherwise. But actually, right now, I thought I was mostly done. So I'm going to copy and paste some, this is just a typo, but copy and paste the examples. But I was also just very mindful of a lot of, I think I was just worried about this problem. On kind of like a brief scan that looked right to me, but it actually was wrong. So I think it's good that I keep testing everything. Like for example, actually this is maybe okay, but but for Havana, I think it was okay just by luck, actually. I will go for the. They went out time limit. That's not good. Oh, that's too. I think this is the one where obviously one of the answers is wrong, and I was like, okay, why is that wrong? Because it's probably the empty string. So I mean that's the only reasonable thing. So I was like, oh, let me add a +1. But then once I did this and I test, it seems like yeah, it seems like my results were one off. Like it was missing one query. So I was like, okay, actually, I just I'm off by one, but in another place. So that's what I end up doing, and I think that's all there is for this problem. Submit, got accepted, and the next one. Number of ways to stay in the same place after some steps. So this one, it's a very standard counting dynamic programming problem thing where like just counting the number of paths from X to Y is a dynamic programming thing. Though I think now that I think about it, you could also use like some matrix multiplication type thing to get it much quicker. Though that's not necessary for this problem because steps is only it's less than or equal to 500. I also look at the wavelength and I was like 10 to the 6. But I was like, okay, that's just a misnomer because it's a red herring because steps can only be 500 and you can only move left or right one one move per step, so it's always going to be less than 500. I even put in this check here because I scrolled back up to kind of read it just to make sure, but I don't even think this is necessary to be honest, but it's fine either way. All it does is make sure that the space complexity is better, but it's not a big deal, I don't think, because I didn't use an array, I use a default dictionary, so it wouldn't have made a difference either way. But everything from here now is it's very standard dynamic programming. So take a look. I don't think I have see if you can spot something that I missed from the problem right now from the end, but and you'll see it very quickly when I solve it. But yeah, but that's kind of the problem right now. So I will leave you to my past Larry. Though I guess if you're watching this, all the Larrys are past Larrys. But yeah, and yeah, definitely just this is one of this what's it called I call it prefix dynamic programming, where like you don't care about all the prefixes, you only care about the last state. But yeah, but that's mostly it. So yeah, see y'all in the pit. Off by one probably. Oh. Off by one. So our wavelength is maybe I didn't need this actually. Oh, poop. Well, I'm glad this wasn't a real contest. I did remember reading this, but I just forgot. Silly mistake. I probably would have made this mistake in the real contest just because there's a lot of pressure to kind of get the speed right. Oh, I guess I should copy this one. But, oh well. What? Okay. Whew. All right, let's go over the test. I would have, wow. I mean, well, it's 20 minutes because I have plus 5 minutes, so this is actually not set. But that would have been apparently a really good contest if I had actually participated. All right, let's go over my yeah, let's go over my solutions and then maybe we'll cut and do regular Leetcode afterwards. But that's a little unfortunate though, because definitely, well, I guess it's about 15 minutes in. So I mean, even yeah, because more people are gonna finish these, and then okay, well, hmm. Well, I mean, I guess okay, like I did okay. Clearly, now I wish I did that contest, but kind of. I mean, I was hanging out. It's fine. It doesn't prove anything. But cool. Let me just go over my solutions, and then we'll. Well, I guess it doesn't actually show up until later, so I'll go over other people's solutions afterwards. But then maybe and then see what else I can learn from it. Should have done. This should have been faster anyway. But wow, these people are fast. 11 minutes. Finish 15 minutes per 5 minutes penalty. Okay, cool. So minimum time to visit all points. I think the first thing I noticed here is that you have to visit. Well, I guess I just read it. I guess there's no first thing I noticed, but at first I read the problem, and here 1 second in one move. I think I double read this just to make sure I can move one horizontal, vertically, or diagonally. That means that ideally you want to go diagonally until like between two different points, you have to go diagonally until you're either under it or basically the same vertical line or the same horizontal line, and then you add the the how many steps you have to do that. I think that's pretty straightforward. And in that, it's just the maximum of you have to go either further left or further up or negative version of those. So that's how I kind of approached it. And then the second thing I noticed here was that you have to visit the points in order. So then I mean, there's no way around it, right? You just have to kind of look at every adjacent points and then do the math. So there's no tricky thing about like permutations. I didn't even look at the end in this case because I knew for me I have to visit them in order, so that it's going to be linear in any case. There is some like if you're a Python like not even I wouldn't say even expert, you're just like a big Python person. Probably you notice that I probably could have used zip here but I think if I was optimizing uh, but yeah, if I'm optimizing for a competition and I'm optimizing for speed, I think I just go with not looking up the syntax, right? So I did something that's a little bit more verbose, but I also knew it was going to be right, so I didn't worry that much about it. Um, yeah, so that was the first one. I mean, it's supposed to be easy, so it was straightforward. Yeah, account service that communicate. Yeah, I don't for this one. My intuition. I actually when I first looked at it, I thought there may be some what's it called like connected components thing where you have to do like a depth first search and then just like go around and stuff like that. But But then I noticed that it actually just needs to be in the same either vertical or horizontal line with another one, another computer in this case. And I took a look at the N's and the M's or whatever. And it's 250. So I was debating doing something like N to the fourth or something just to like match anything. But then I just figured that you could actually map them to like the X and the Y's and then just go through it again. So I did a two pass thing where, okay, if there's a computer at the coordinates ij, then you just mark that X coordinate as being used and then coordinates being used, and then I just count it again, being with if there are more than one computer on that either horizontal or vertical axis, then we count them. And this is linear in terms of the input, which is n times m, so it's 250 squared. So didn't really worry about running speed, and I kind of got this very quickly. So yeah, I mean, I just had the insight very quickly, which sometimes is luck because some days you're maybe not as ideal or optimal or whatever. Uh, cool. So that's kind of that's how I looked at that one. Search suggestion system. Actually, this one I had the most reservation about in the sense of performance. Also, I had an off by one because I always forget if this should be plus one, but the test cases was good. I think what I end up doing, I mean, there are definitely optimizations that I could have done, but I wasn't sure I needed. I think the trickiest thing was actually now that I looked at it, I actually misread this. I actually misread this constraint because if I Huh, actually. Yeah, actually, maybe I guess in retrospect, I didn't need to be that reserved about or conservative, or at least worried about the constraints. I actually thought this was each each string could be 20,000 characters versus what's apparently actually just a summation of them. So I actually didn't have to worry about that much because I was worried about 20,000 times 1,000 characters. So in some ways, like maybe 20, I mean, 20 million characters, which maybe is like 20 million or like 20 megs or whatever. But I guess it actually is the summation, so it's not so bad. I didn't actually have to worry about it at all. But I just did the very naive thing of basically look. So you, even that said, because if you do some like n times m type thing, and then you have to do like a prefix thing, it's gonna be too slow. Yeah, it's gonna be just too slow for like because each of those character lookups you have to do I don't know potentially a long lookup. So it's a million times some constant, some big possibly big constant. I think the first thing I actually did when I typed was I sorted the input for products because I knew that that's the result that we want to return in some sorted order. So it almost always is beneficial to sort to that order sometimes. Or at least that's my intuition for this farm. I did a yeah I and then I created a reverse lookup table on just like the prefix of each of the product. So then I could look it up in constant time pretty much. Um, yeah. So this is actually but and this takes actually the same amount of this time. So the sum of all the product lengths. So it's actually not bad, not that bad. I got this one very quickly. And a number of ways. This is actually a very standard dynamic programming problem. That's why I was able to uh, uh, go through it very quickly. I mean, there are definitely like a little nuance and trickiness. The only sad thing about me is that about this for me is that I definitely saw the module and then I just like, forgot about it because I was trying to get this out and I was trying to um, yeah figure it out because I also misread this all length a little bit. I thought it might be uh, um, like I thought it was like symmetric to the left and to the right, but that's just setting the constraints, which I fixed very quickly. Though I still took 5 minutes, I could have been a little faster on this farm, and I have a penalty of 5 minutes because I forgot the mod, which is such a silliness. Um, that said, and there's some optimizations that you can do, but I end up no, I know that this is for n is 500, so I know that at worst, a point is only going to move 500 places, so that's what I did. So it's 500 square, and Also, I guess this is more a little bit of a red herring, and that is 10 to the 6 for the array length, but you never need to keep track of array length for anything. Um, I mean, except for here, but you don't need it for anything. And also, the most you can go after 500 steps is just 500, right? So I think that's obvious. And then beyond that, it's just a very standard dynamic programming on the iCode, like prefix something something dynamic programming. It's not a great explanation, but yeah, definitely go into that a little bit. But yeah, so that's my contest for this problem. Where would I have ended up? 16 would have been not bad. I mean, um, obviously this isn't super real, so like, but it is what it is. You do the best you can, right? Um, cool. Uh, yeah, we're gonna do the commentary on this later, but uh, cool. Yeah, let's check out everyone's solutions. Just see what I can learn. I would have finished on the first page even with one error. I would have finished all the problems in 15 minutes, which would have been six or so. But with the penalty, I would have been 20th, I want to say, or 21st, 20th, 21st, which would have been great. But you know, it is what it is. Sometimes you can be in awe of them. Let's see what I can learn. Um, this is Python. I mean, I think this one is straightforward. I don't know how much there is to learn. I mean, this is actually in C++. It is pretty straightforward. Oh, and yeah, and I think we all did it essentially the same way. I mean, I just taking the max, so like that is the smallest you can get the code, probably roughly. Okay, and then the second one is the one with the host the counting vertically and whatever. So I think wow, I did it so quickly. Um, let's see. So actually, in Neil Wu did the thing where it's n cube, or not n cube, but r times c times r plus c. So it's effectively n cube ish by just going up and down. I guess that's still fast enough. So good for him. It's less thinking. See if other people did it. Okay, it's not loading. Oh, okay. Uh, yeah. I mean, same concept. Just subtracting ones where this is the only thing in the column and row. So the negative of what we were doing pretty much. Okay, let's look at the third problem. Yeah, I guess everyone did the same. Well, actually, this is some kind of binary search thing. Oh, okay. I guess that makes sense too. That's actually the other way I was thinking about doing it, which is that you sort the products and then you binary search, and then you just based on the prefix, and you just get the next three words, which is pretty straightforward too. But I'm always a little wary about binary search. Actually, I could have done it in quickly too, so maybe that would have been worth it. But yeah, there's also a lot of binary search because this is actually way better in theory in that it is way less efficient, way more space efficient, and that uses less space. Maybe that's the way I should have done it, but I got it pretty quickly, so it didn't seem to matter. And the last one, yeah, I mean, again, is a straight dynamic programming problem. Missing the big mod kind of hurts, but otherwise it's pretty straightforward at this point. I mean, I don't know if there's anything tricky about this in terms of dynamic programming. I think here, I don't know whose solution I looked at, but yeah, and people even actually used the steps squared algorithm, which is even better, and also did the min. Not even, I mean, it's worse on memory, but it's not that much worse that like n squared memory is good enough for this problem. So that's what people did. But yeah, so I guess maybe next week I will actually be on this contest and hopefully do well. This would seem like a one that I would have done. Done pretty well, top 20-ish, but it is what it is. Anyway, see y'all next contest. Bye bye.